we will learn this concept called Tower of Hanoi, which has got a very good use of recursion. So let us firstly learn what is Tower of Hanoi.
The problem goes like this, that suppose there are two, say, books over here. Now these two books are present in position A. This is the source, position source. This is the position destination, and this is the position intermediate. So this is the source position, this is the intermediate position, this is the destination position. Now from the source position, these two books will have to be brought to the destination position, but at no point of time the smaller book should be below the bigger book. I repeat, this is the source position, this is the destination position. From the source position, you have to bring these two books to the destination position, and at no point of time a smaller book should be below the bigger book. But the books will have to be brought one by one. You cannot pick up two books at a time. This is wrong. I am picking up two books. No, two books cannot be picked up at any point of time. You can only pick up one book. You have to bring both two books to the destination position, from the source position to the destination position, but you have to bring one by one. At no point of time the smaller book should be below the bigger book. How to do it? If I bring it from here to here, if I can pick up, I can pick up only one book, so I pick up one book. I bring from here to here. If I bring from source to destination, then the problem is, now if I pick this up, where will I keep? If I keep it here, the bigger book gets above the smaller book. So no, not allowed. For that, so to solve the problem, you have got this intermediate position in your hand. So now see how I can do it. These two books are to be brought from source to destination, picking one book at a time, but at any point of time should not be the smaller book should not be below the bigger book. So what to do? I pick this up. I keep it in the intermediate position. Now I pick up the bigger book. I put it in the destination position. Then I pick up the smaller book. I put it in the destination position. See, the two books are now kept. That smaller is above the bigger. At no point of time the smaller book was below the bigger book, and at no point of time you pick two big books at a time. I repeat it once more. Repeat the solution once more. These two books to be brought from the source position to the destination position, picking one book at a time, and at no point of time smaller book should be below the bigger book. So what to do? How to do? I pick this one up, keep it in the intermediate position. Then I pick this one up, I keep it in the destination position. Then I pick this one up, keep it in the destination position. So problem solved. Easy for two books. What for three books? Now say suppose you are given three books. See, three books. These three books are there in the source. You notice bigger book at the bottom, just above, a size below that, above that, and a size below that, above that. I will have to bring these three books from the source to the destination, one book at a time to be picked up. At no point of time smaller book should be below the bigger book. How to do? How to solve this problem? Very simple. You see how I solve it. I pick the smaller one up, keep it over here, destination. Then I pick this book, keep it here, intermediate. See, I'm picking one book at a time, and not any time, at any point of time smaller book is above the bigger book. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. See, smaller above bigger. Then I pick this one up, keep it here. So solution done. At no point of time smaller book was below the bigger book, and always one book was picked at a time. One more time I will solve it very quickly. See, 3 books, one after the other. Smaller book above, bigger book below. One book at a time, source to destination, transfer. How to do? I pick this one up, one book at a time. I pick this one up, keep it here. Again, one book at a time possible. Pick this one up, keep it here. One book at a time possible. Pick this one up, keep it here. See, smaller above, bigger. Then this one I pick up, keep it here. Then I pick this one book at a time. Keep this one up, pick this one up, keep it here. Then I pick this one book, and keep it here. Smaller above, bigger. Then I pick this one up, keep it here. Done, solved. So solving for 3 books was more difficult than solving for 4 books, solving for 2 books. You understand? Solving for 2 books was easy, solving for 3 books was difficult. Now suppose you are given 4 books. 4 books. See, even more difficult. Even more difficult. 4 books, how to do? Difficult. If I have to do it, definitely I can do it. But it is difficult, you will agree. Can I think like this? I solve the problem for 3 books. Firstly, I solve the problem for 3 books. Don't think about the 4th book. Solve the problem for 3 books. I think I know the solution for 3 books. For 3 books, I have solved the problem a while back. Just a while back, I solved it for 3 books. So for these 3 books, I solve the problem. What I solve? I bring from source to intermediate using destination. I had done source to destination using intermediate. I solved for 3 books. Now I solve for 3 books from source to intermediate using destination. So this is possible. I can do it for 3 books. I can do it for 3 books. I do exactly this. If at any point of time I use this, doesn't matter because this is the bigger book. You see what I do? For 3 books I solve. Forget about the 4th book. For 3 books, how do I solve it? I have to bring from source to intermediate using destination. I pick this up, keep it here. I pick this up, keep it here. I'm doing only for 3 books, remember. I pick this up, keep it here. 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 Solve for 3 books, source to intermediate using destination. Now I move the last book from source to destination. Possible? Then I again solve the problem for intermediate to destination using source. Intermediate to destination using source. Can be done. Intermediate to destination using source. Pick this up, keep it here. 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 I have found a recursive solution. What I mean to say is, if I am given for 4 books from source to destination using intermediate, I will do it for 3 books, source to intermediate using destination. Then the last book from source to destination, and then the 3 books again from intermediate to destination using source. Problem solved. If I have to do for 5 books, if there is an even bigger book below this, I don't have a bigger book than this anyway, but if I have an even bigger book than this, assume that a bigger book than this is present, I will do from source to intermediate for 4 books using destination. Then I will pick the bigger book, keep it to destination, and then I will do for 4 books from intermediate to destination using source. So for n books, I will do it for n minus 1 book from source to intermediate using destination, then the last book from source to destination, and again the n minus 1 books from intermediate to destination using source. This is how I will solve the problem recursively.
So I believe that you understand that Tower of Hanoi for n books to be transferred from source to destination using intermediate is a problem. Tower of Hanoi, n books, for n books to be moved from source to destination using intermediate is the problem. And the solution to the problem goes like that you firstly execute the Tower of Hanoi, not for n but for n-1 books. Move the n-1 books, leaving out the last book at the end. The books n-1 which are over the last book which is at the end. Move those n-1 books from source to intermediate using the destination. Doesn't matter because the last book is at the end, so anything you keep above that is allowed. So move from source to intermediate using the destination. That you do for the first n-1 books. Then the last book, execute, that is move nth book, or not nth book, just write move book from source to destination. That is what I did. I firstly executed the Tower of Hanoi for n-1 books which are on top of the last book, and I moved them from source to intermediate using the destination. Now I move the last book from source to destination. Just one book I pick up, the last book, and keep it to the destination. Now again I can execute the Tower of Hanoi. Again I can execute the Tower of Hanoi for the remaining n-1 books, which at the moment, where is it present? It is present in intermediate position. So move those books from intermediate position to destination position, this time using source. See what I have done. n-1 books then move from the intermediate. Firstly n-1 books move to source to intermediate. Destination was used. Then you move the n-1 books from intermediate to destination using the source. In the meantime, you move the last book from the source to destination. So you are doing this whole thing. While doing this whole thing, see, for n books, you are assuming that for n-1 books it can be solved. So for n-1 you will assume that for n-2 it will be solved. For n-2 you will assume that for n-3 it will be solved. Say for example you are given for 5. You will assume that for 4 it will be solved. Then you will be assuming that for 3 it will be solved. Then you will assume that for 2 it will be solved. Now for 2, solution is really that easy. So you can write the solution only for 2 books. For 2 books, what is the Tower of Hanoi solution? See, the solution, if it is for 2 books, the problem now goes like this. For 2, not for n. For 2 books, if you have to move from source to destination using intermediate, if you have to do for 2 books source to destination using intermediate, then the solution for that is really easy. What you do? You move the book from firstly source to intermediate. The top book, there are 2 books. So the book on top is the smaller one. You keep it in the intermediate position. Then the next book, which is the bigger book, move from source to destination. Now the smaller book is there in the intermediate position. Now you move that from move. Now you move that from intermediate to destination. See what I did. I repeat once more. What I did was, I firstly moved the smaller book from source to intermediate, then the bigger book from source to destination, then the smaller book from intermediate to destination. So for 2 books I have solved it, as I have shown a while back. So this is the solution of Tower of Hanoi. So if I have to write it in the format of a C program or a C function, I know return will be void because the printing will happen within this. Now void Tower of Hanoi for n, maybe books, maybe plates, whatever, in 10, from source. The source may be capital A, so let it be a character from capital A to capital C using capital B, can be like this. So let the source be a capital thing, a character thing. So character source, let source be character. Why? Because it is a capital A or capital B, that may be the source, or A or B, that may be the source, whatever. So from source to destination using intermediate. This is the job, Tower of Hanoi, to be executed. So you know that the solution exists if n equal to 2, and for other values of n you will do it using recursion. So firstly you check if n is equal to 2. For n equal to 1, what is the solution? For n equal to 1, the solution is move from source to destination. That is the only solution you have. For 1, move from source to destination. That is the solution for n equal to 1. But for n equal to 2, it is interesting to write the solution. For n equal to 2, you firstly move from, so printf, you are just printing the steps. The steps are to be printed. So printf move from source to intermediate. You are writing the solution for 2 books. Move from source to intermediate. Next solution is printf move from source to destination. Next job is, so firstly you move from source to intermediate. Next job is source to destination. Is not it so? After everything you put a /n so that it goes to the next line after every step. And lastly you move from, you just print the step, move from intermediate to destination. Is not it so? You move from source to intermediate and source to destination, and then you move from intermediate to destination. Job done for 2 plates, for 2 books. For 1 book it was even easier. For 1 book you could have written move from source to destination, job over. Then also it would have worked. For 1 book also it would have worked like that. Anyway, but I have written for 2, it sounds interesting. However, else if n is not equal to 2, you remember that here you do an automatic return. If n equal to 2, from there you do an automatic return. Is not it so? Is not it so? Anyway, so here I start with the else. What to do? If it is not n equal to 2, then the solution was, firstly you execute the Tower of Hanoi again. You execute the Tower of Hanoi again, this time for n-1 books. Move from source, not to destination, but you check out what you written, source to intermediate using destination. So move from source to intermediate using destination. Is not it so? The next step was the nth plate to be moved. So next step is printf move from what? Source to destination. Move from source to destination. That is your next job. Move from source to destination. But you see one thing. This is source to intermediate. Should you write like this? You should write like this. Person C to person C. Is not it so? You should write like this. If n equal to 2, then you move from person C to person C. That is, move from source to destination. Is not it so? Next you move from source to intermediate. Sorry, first step was source to, not destination, but intermediate. Wrongly wrote destination. Source to intermediate. Next job was person C to person C. Person C to person C. That is source to destination. And the last step was intermediate to destination. You should write like this. Person C to person C. That is intermediate to destination. It is better to write like this, is not it so? Here also, printf, move from source to destination. Move from person C to person C. That is source to destination. And finally, again you call Tower of Hanoi, is not it so? The last step was again calling Tower of Hanoi for n-1, intermediate to destination using source. So Tower of Hanoi, n-1, intermediate to destination using source. Do you understand this? So n-1, source to intermediate using destination. Then move from source to destination, the last plate. And then from intermediate to destination using source. So what have I done? I have just written a recursive program. Whatever solution I had given, I have just written it in the code format. Absolutely same thing like this I have written. So let me comment out this portion. And I will try to execute this. But for that, from main I must call. So let me call Tower of Hanoi, it is void. So let me call just Tower of Hanoi, I need not receive it anywhere. Let us do it for four books. From source, let it be capital A, to destination, capital A to destination, source to destination, check out, source to destination using intermediate. So A to C using B. Let us write like this. A to C, C should be the final destination, using B. Can I execute this program now? I should be able to execute this program now. So let me try to execute this program. So let me save it first. Now I execute this. For how many? For 4 plates. Oh, one thing. After every printf, did you put a /n? Okay, I did not put a /n here. So let me put a /n. Now it will execute very smoothly. You will be able to understand for 4 plates. Alt enter. See, for 4 plates, entire thing to be shifted to C. So firstly, the smallest plate from A to B. Then the second plate from A to C. The next plate from B to C. Possible? Because C contains the bigger plate, so B to C. Then A to B, then C to A. Please check this yourself. Take 4 books and mark 3 positions A, B, C and just execute this step following this screen. Whatever is written in this screen, please follow that screen and do the steps one by one. You will find that the solution has been given. to see the solution orally or just to without taking the help of 3 books. If you want to do it, let me check for 3. Let me do it for 3 because for 2 the solution was given. Let me do it for 3. See, for 3, A to C, A to B. So 2 books already move. So C to B. So 2 books already in the B position, intermediate position, 2 books present. A to C, so smallest book in C. After first line, smallest book in C. After second line, the second book in B. Smallest book in C, second smallest book in B. C to B, so smallest book in B now, above the second smallest book. Then A to C, largest book in destination. Then B to A, smallest book in source position. Then second smallest book, B to C, second smallest book above C, above the largest book. Then the smallest book from A to C, smallest book above the top. So the steps have shown you that how the steps are to be done. Do you understand this? Even you can do it for n equal to 1. If you do the solution for n equal to 1, if n equal to 1 was your last step, if you want to do the last step as n equal to 1, then only one step is needed. Source to destination, nothing more. See, this is not needed, this is not needed. If n equal to 1, if you take the solution, last solution, that is your end point as one book, then for one book it can be done very easily. Just move the book from source to destination. No other steps are needed. Move one book from source to destination. Job done. Then also, will it execute? Will the problem be solved? Run it and see. For 3 books, see, solution still exists. Same thing. I had done it for 2. But for 1 also, you can say that your endpoint is not for 2. Your endpoint is only for 1. Because 2 can also be solved using 1. For 2, if you use this, for 2, you do it for 1. Source to intermediate using destination for 2 books. Then you move from source to execute the source to intermediate using destination. Then you move the book from source. So this solution will exist. If you do it for 2 books, then also you can use this solution, and for 1 book you provide the actual solution. So this part will not be needed then. Only source to destination. The solution for 1 book is only move from source to destination. So this way also the program can be written, which I have done. So I think you understand. See, writing this Tower of Hanoi program or the steps without using recursion, how difficult it would have been. It would have been really difficult to write it without using recursion. But using recursion, such a complex logic has become so easy. You just did for n books using the help of n-1 books, and you only specify the endpoint. That is how recursive programs are done. Solve the problem for n numbers using n-1 number and provide the solution for the smallest number, maybe 1. Your job is done. So let us end recursion over here. We will come back with other topics. Thank you so much.